So yeah, how about we guys jump into a demo? So what we're gonna do here is we're gonna spin up just two Postgres instances with Docker, one master and one standby for simplicity. And we're gonna make one as a master and we're gonna make the other as a standby. We're gonna connect the standby to the master. I'm gonna show you how to do that. And then we're gonna make the master aware of the standby because we have to do this two-way configuration to get this right. I found difficult to actually find a working example on Postgres 13 because it's brand new. Even the one on Porcona is just not clear enough. So I had to go through the doc again and make the simplest possible configuration for you so you get this working, right? By any chance, this is not best practices. I'm not showing you best practices here. I'm showing you how it works, and I'm gonna tell you that, oh, don't do this. I'm gonna slap you on the head. Oh, don't use the Postgres user as a replication. Obviously, this goes without saying. But if I started doing the create user and replication, this kind of pollutes the goal of what I'm trying to show you, right? I'm trying to give you what exactly how it works. So simplest way to get it starting up and running so you can just test and taste this thing, okay? How about we jump into it? All right, guys, how about we jump into the demo? So I have Docker installed on this machine, and I am going to spin up two Docker instances that are each Postgres instance. And I'm going to use Postgres 13 because I like the risk. I like to I live in the edge, babes. I live in the edge. So here's what we're going to do. So we're going to create two Docker instances. We're going to name the first one PG P master, and the second one is P standby, right? And based on those, each we're going to have its own port, and each going to have its own volume that I'm going to mount on my host here. So let's create a folder here. How about we do that? I'm going to code a folder called replication, stands for replication. I'm going to throw my data for both master and standby here. Why? Because we're going to muck with the data a lot to get this right? First of all, we need to spin up the master, and then we're going to spin up the standby. These are completely distinct Postgres instances, obviously. Then we're going to copy the entire data from master to the standby. That's a requirement to get the replication right. It has to be exactly identical to start with, and then you start building on top of it. If those are different, you're gonna get a lot of errors, and I got this all the time. So how about we do that? We're gonna do docker run -- name p master. We're gonna call it the Postgres instance master. I'm gonna expose it to 5432. That's the default port, 5432, right? So it's exposed to the host. That's very important as well. And so the master is running 5432, right? This is always the same because it's the same instance that we're running on, right? It's the same Docker instance. And then we're gonna do the volume. And the volume here is essentially just inside the replication folder. I'm gonna create a folder called data, right? This will create a folder called data inside this, and I want to map this to the Postgres data folder, which is essentially in the Docker instance, which is var lib, I believe, PostgreSQL /data. And that almost it. So now we do e Postgres, the environment variable password. I'm gonna call the Postgres user Postgres. That's the same password. Bad idea, obviously, but you guys know what I'm doing here. This is not best practices. This is just showing you how to do things. And then if you want to build something massive, if you want to make this into production, you actually sit down and think how to do this right. You build an architecture. It's not like that at all. You cannot do it in 5 minutes. So now the final thing is just do Postgres. And I'm gonna detach this so that I'm gonna use the same terminal to do other thing. How about we run this? All right, looks like you have to specify the whole path. So I'm gonna do users, Hussein Nasser, Postgres, and then replication, and then data. Let's review the whole thing again, guys. So docker run pmaster, that's the name of the Docker container, that's the port, and that's the path of the volume. What I'm going to do here is I am going to change this to master data underscore data. So I know that is actually the master data, right? We want to differentiate between the master data and the standby data. So I'm going to rename this folder to be master data. So that's the folder that's going to get created. And then this is what we map to. Looks good. And finally, once we get this right, we run and docker logs p master. Looks like we're running. Looks like it's good. Looks like it's good. Creating files, configuration files is good. So let's test this thing. P master. So we have now a folder called P master data. Awesome. Okay. So how about we create the standby replica? All we have to do is just change some variables here. So I'm going to call it P standby. It's not running in 5432 because that's used now. I'm going to 5433. And then I'm going to match this instead of P master data. No, it's going to be P standby data, its own folder. And that's it. Just like that, we have two Postgres instances, right? They're not identical right now. But if we go to P standby data, we can see all the data right here, the Postgres data, very critical. And then if I go to P master data, you can see it's all there. The next step is I'm going to stop both instances, P master and P standby. Why? Because I need to actually copy the content of the master to the standby. And it's very simple to do this because now everything is in my folder right here, right? So all I have to do is just do move P standby data to P standby data backup, right? And then I'm going to copy -r, which is recursive, P master data to P standby data. Exactly copy the whole thing as is and then paste it. And just like that, we now have the same folder, but we tricked the other instance so that it reads almost the same content. That's very critical for replication. Another process is to do PG backup. A lot of people do that. I like to do this. That's another example just because it's easier. I don't want to deal with backups and all that stuff. So this is way easier. Now we have two databases. Now let's start this up. Make sure they are working. P start, docker start, P master, P standby. Awesome. We're almost there. We just barely created this thing. So the next step here is we need to go to master. All right, guys. So what we need to do next is update some file only in the master, right? So just let's go to the master data here, and then let's vim the PG-HBA configuration. Very, very critical file. And what we need to do to this file is do an insert, and at the end, I'm going to add host replication. I want to enable replication for the user Postgres. Bad idea. Everybody tells you don't use Postgres as a replication. Yeah. Also, don't use the password named password, right? For your passwords, obviously. Everybody knows that. But for simplicity reason, I'm going to use the same Postgres user, which is an admin. Don't use an admin. Use a proper create user and only create so that it only allows to do replication. So you want a user that is allowed to do certain things, not everything. That's a bad idea. But we're testing, so what's the harm? So, and then we're going to do all, and then finally MD5. And that will allow the master to the standby to connect to the master in replication mode. Awesome. So now the next thing we're going to do is we're going to need to jump into the standby replica. So let's go to the standby replica. And it's very easy because I'm just going through different folders, which is awesome. This is now I'm in a standby data, right? So now I'm going to do Postgres config. And now this is the critical part. We want to edit one configuration in the postgres.conf file in the standby. And that is called, I think, primary connection info. There you go. We're going to enable that. That will allow us to connect to the master node. And here's the connection string to do this. Application name, the first important thing. Why? This is this is a unique identifier for each backup or standby node. You have to give it a name. So I'm going to call it standby 1, right? That's the first name that came to my mind, right? And then you use the same application name. It has to be case sensitive, by the way. And then you reference it on the master so that the master are aware of what nodes it wants to connect to, right? Otherwise, if you allow anyone to replicate from any database, that's just a security flaw, right? That's why we have this factor authentication here. Then we add a space and we do host equal, what's the host name on my master? It's Hussein Mac, which is the same. They are all on the same machine. And since I exposed them to the port, I can safely use this name, right? And then what's the port? It's 5432. Remember, that's the master. Awesome, awesome. And then finally, what's the username? Postgres. Well, you can use replica user or replicator or whatever user you want. But for me, it's Postgres. It's just testing. And what's the password? It is also Postgres because we ran this thing with Postgres. And hopefully we don't have any errors because I ran into errors sometimes here. And that's the only change that we do in the configuration on the standby. You can change some other configuration, but I'm not going to go this in this video, right? There's so many knobs to turn here. So we save. See, it says the standby server. These things are only in the standby. They are ignored the master server. So we save and write. Awesome. Guys, did I mention that I have to stop the both standby and the replication? If not, just make sure they are stopped. Well, I don't remember if I stopped them or not. So now, the other thing you need to do, which is weird, is in the standby, which is this, you have to create, in the same folder, you have to create a file called standby.signal. This makes this instance a read-only instance and a standby instance, right? So now we have finished with the work in the standby. Now we need to jump back onto the master, right? Which is what? What is the master? P master. And now we need to change one slight thing in the configuration. And it's called, I believe, synchronous. Let's search for synchronous comment. By default, it's on. That's what we discussed, synchronous versus asynchronous, right? What else? Synchronous standby name. That's what we want. So the synchronous standby name, because we were going to do synchronous operations, right? All we have to do is just literally reference here, and that's the tricky part, guys. You have to, this is a syntax thing here. So you do, for example, first one, and then you specify the application names, right? So if you have like a standby, let's spell it right, hopefully standby, right? So this means give me, allow the commit as long as at least one of these servers commit. And obviously this is a little bit silly because there is only one server, right? But if you have like another standby server called standby 2 and the application names, remember here guys, you put the application names. Standby 3, then you say, okay, I want the first 2, or I want any 2, for example, right? This means like these 2 has more priority on the third, right? And so on. But my configuration is only this, so it's very simple. So all I have to do is just change this thing. Bum, and then hopefully we don't have any errors, right? And that's it. So now, how about we don't have any problem. Let's start P master and P standby, and let's hope for the best. So let's look at the logs as well. There's another way to look at the logs by doing Docker logs, right? Docker logs, P master. Standby 1 is now a synchronous standby with priority 1. Look at the beautiful thing. So now the master is aware. Was this a master? Yes, it is a master. And the master is now aware of the standby 1 replica, right? And now if I go to the standby, it is also aware. It says database ready, start streaming wall from the primary, right? So what is the write-ahead logs? Because that's what actually changed, right? Write-ahead logs essentially is a very small file that records the transactions. So any transaction on any table goes to this file first, or it's usually in memory and then goes to disk. And this is what the databases exchange, essentially, all the walls. Awesome. Looks like we're good, guys. So now, what do we need to do? Can we test this thing? So far, we didn't actually enter any database. So how about we actually get into one of them and test? So what I'm going to do here is I'm going to use this terminal, right? And execute pmaster, and let's call it psql-u Postgres. That means enter the Postgres mode here. And then I'm going to show you that things are working by doing a select statement. Select star from pgstat replication. And that tells you that, hey, by the way, if this is empty, that means you don't have any replication. But look at this. We have one row. It says streaming, and I am streaming, and it's a synchronous mode and all this detail, and it's called standby 1. And this is the user. Bad idea, but who cares? We're testing. So that's the master. I'm going to create another tab here. And this will be my standby. So docker exec -it p standby and psql-u Postgres. Now I am in, this is the standby. Yes, this is a standby, and this one is the master. So now, if I create a table here, create table, test, ID integer, and let's say let's say t varchar 2. This is not a record. Varchar. I just created a table. If I go to this instance and do describe test, look at this. The table magically appeared on the other instance. Why? Because we're writing to this. However, if I go here and do create table test1 ID, I don't know, integer, and then I do t varchar 200. Look at this. We're getting yelled at. You cannot write to a replica. You cannot write to a standby backup. It's a read only. So now if I do select count star from test1, it's 0, right? And if I do insert into test, and let's say, I don't know, ID, and yeah, it's just the ID, and then do select random times 1000 from generate series 10,000. So I'm inserting random number here. As I query here, it's still 0. Well, all of a sudden appeared. That is extremely fast, guys, because it's in the same instance, right? But now I am seeing my queries appear here, and obviously they are also here. So this is pretty neat. That's exactly what I wanted to show, right? If I drop the table, drop is a little bit harsh, but if I change anything here, that change will gonna appear. So let's do alter table test add column. Hopefully I get the syntax right. I'm bad at SQL when it comes to alter. I don't know, G varchar or just v integer. Is that how you do it? Oh, how about that? I did it. I got it right. Look at this. It shows up immediately here in the second instance. So that's essentially what we want to show, guys. I can delete rows. I can truncate table test, right? And the moment you truncate it, obviously, all the rows are gone from the replica as well, right? So that's essentially replication in a nutshell. How about we jump back into the slides and complete this video. Guys, anything, all the resources and stuff like that will be available below. Let's jump back into it.